Hello and welcome to our guardrail training as it relates to our newly redeveloped Index 400 design standard. We appreciate your interest in Guardrail and hope that some increased understanding of its function will play into our mission of providing safer roadways for the traveling public. Really, at the end of the day, public safety is always among the highest concerns for roadway designers, and so again, we appreciate your interest here. My name is Richard Stepp with the FDOT Roadway Design Office in Tallahassee. My responsibilities concerning the guardrail included developing the new index sheets, the new Instructions for Design Standard or IDS, the new specifications, and the new length of need design tool, which is an Excel-based program. My contact information is listed here, as it should also be shown in the PDF of this PowerPoint presentation. Please feel free to contact me with any questions you have concerning guardrail. I'd also like to give a shout out to my colleague Durwood Shepard. He had played a significant role in development of this standard, as he did a lot of the legwork in gathering the latest information from around the country, including multiple committee meetings, so that we could then provide some of the most state-of-the-art policies in our standards. Durwood is our Design Standards Publication Manager, and his contact information can be found on our RDO website. This course is broken down into 4 modules. Modules 1 and 2 will provide an overview of our new standard index sheets. Each one of these modules is about an hour and 15 minutes long. We will then move on to Module 3, where we review the new Instructions for Design Standards. The IDS by nature will cover some of the same topics we had seen in the index sheets, so it will provide a nice review. We'll also go a little bit more in depth in terms of the roadway engineer's requirements for the contract plans. And Module 3 should also be about an hour and 15 minutes long. And then in Module 4, we'll take a look at our new length of need design process using our Excel-based design tool. And we'll go through several examples in that module, which should run about 50 minutes long. So we've given this course live for each of our 8 districts, and we always start off the class by asking for a show of hands of who's interested in this class. And so in general, we get about 60% of the people raise their hand as roadway designers, and then it's usually about 10% of the remaining 4 of plans reviewers, project managers, construction contractors, and maintenance personnel. And the idea is that we would help this course would be beneficial to everyone. Construction contractors and maintenance personnel would mostly benefit from the review of the index sheets. They could essentially get some exposure and get to know some of the nuances with that and become more familiar with what designers are looking for. But primarily, the course has been geared towards what types of things the roadway engineer should be thinking about in order to use Index 400 for guardrail within their plans. And by having that core understanding, it does benefit everyone who would eventually be working with the guardrail, including the construction contractors and the maintenance personnel. Okay, so just a brief overview for what we've done with Index 400 for guardrail. It was a complete restructuring project where we redrew all of the index sheets. We have new specifications, which are currently modified special provisions. We have a new Instruction for Design Standards, or IDS. We have a new length of need design tool, which is an Excel program. And we've modified some of our existing indexes for compatibility. For example, Index 402 for existing bridges, and then we've moved some guardrail connecting details to rigid barriers out of Index 410 and 411 and into Index 400. Now, one thing that I wanted to mention is that Index 402 that handles existing bridges and all of its transition connections to rigid barrier will still remain in use, and it will still use the old style calculation for length of need, essentially using the design tables. And that will just be for the interim period over the next year or so, where we work to update Index 402 to use the new length of need process and the new guardrail length measurement process. And so it's important to understand that Index 402 will use the design length tables as opposed to our new length of need process. And so the length of need process we're about to show you as it relates to connecting guardrail to bridges will only apply for this new Index 400, and it will only apply to new bridges, new style construction that will not conflict with the new Index 400 details that we're about to show you. And so that temporary difference between Index 400 and 402 will be made more clear when they're both released on November 1st in the new ebook. Now, another improvement we've made in relation to guardrail is the revision of the PPM, Chapter 2 and Chapter 4, where essentially all of the roadside safety information was now moved into Chapter 4. Durwood did a really good job consolidating all that information so you can easily find what you're looking for. So anything related to roadside safety is now all in one chapter, Chapter 4. And speaking of that, when we had given this training to all the districts, Durwood had started off the day basically by doing a review of the PPM Chapter 4, and within that had some information as it related to guardrail and where guardrail would be placed. For this training, we're not going to cover that PPM information because it has already been handled. And if you want to see more information on the new PPM, we invite you to take a look at the February 2016 design update training, particularly Durwood Shepherd's portion. And as we know, that really is the starting point for designers in terms of deciding when to use guardrail as compared to other types of barriers. And then also once you've decided to use guardrail, that gives some basic information of what the lateral offsets from the roadway should be. And so that's good background knowledge to have as we move through our guardrail training. And throughout this guardrail training, I will make references to the PPM, and I do have some drawings clipped out, particularly in relation to the offset of guardrail and where it should be positioned. And I also mentioned some of the exact PPM section numbers within Chapter 4 that you should be paying attention to. And with that, we're going to give you the guardrail crash course. And so here's our guardrail crash course. And so you can see we have a nice smooth redirect. Okay, these pictures were just for the punchline, and that pretty much should be our best joke of the day, so you can lower your expectations for our jokes. Okay, so now we're officially getting started with Module 1, which is the index sheets overview. This is for sheets 1 through 10. Just as a reminder, Module 2 will have sheets 11 through 22. You can download that separately. And as a reminder also, this is Index 400. It's now a DSR as of February 1st, 2016. Will then be included as part of the 2017-18 ebook. Okay, so the question is, why change? Why do this whole redevelopment process? So we'll start off with clarity, updates, and effectiveness. The idea is that if things are more clear, the contractors and designers can spend less time trying to figure out exactly what we're trying to convey. They could spend more time on project-specific needs, creating things more safely for the public. Also, if things are more clear, the contractors out there will have a better chance of getting finished product that we want. Also, updates. As many of you know, we're going to move to MASH implementation. MASH is basically the AASHTO manual for roadside safety hardware. We're going to be able to accommodate larger vehicles with that, and so we feel it's important for the department to move in that direction. The other one is effectiveness. We're going to be moving towards using the AASHTO roadside design guide, length of need criteria. And doing that, things can end up being a little bit more efficient and also safe in the field when we get the exact guardrail length measurement that we're looking for, latest national standard. So just to quickly run through in comparison of the old index to the new index, so you guys have a feel for it. The old index is 34 sheets long. The new index has now been reduced to 22 sheets long. It has a table of contents, so you can more easily find things in there. The old index uses kind of lengthy verbiage and passive voice. The department's moving towards using active voice with more concise verbiage. We've also placed note headings to help you find your way around. If you remember the previous standard, the general note sheet was just completely solid text. If you wanted to find anything specific, you'd almost have to read through absolutely everything. But then moving forward, we've reduced a lot of the text and we're now using note headings so you can find exactly what you're looking for a lot more quickly. The old index uses old scanned-in drawings. They were digitized decades ago. The new index has new drawings to scale, uses the latest labeling practice. The old index includes information for the designer. The new index has designer information moved to the PPM and the IDS. And so the plans preparation manual and the instructions for design standards. I always draw the distinction between the two is that the type of criteria that goes into the PPM is more broad-based. It generally would apply to multiple standards, like barrier selection, what type of barrier to choose, placement of guardrail applies to multiple guardrail indexes, and so that's in the PPM. The IDS covers basically what criteria the designers would need to know to place directly into their plans in order for it to coordinate correctly with the standards. So the specific information involving Index 400 is placed in the IDS. The old index includes specification style language. The new index has the spec style language moved to, where do you think, the specifications? That type of criteria would include things like the length tolerance, height tolerance, material specifications, ASTM specs, that type of thing. Anything that would clutter up the drawings with too much text, all that gets moved into the specs. The old index has the previous NCHRP 350 guardrail transition to bridge railings. Moving forward, as I mentioned, we're going to be using the latest MASH-tested guardrail transitions, and we call that now to rigid barrier. That's going to cover both bridge railings, for bridge decks and approach slabs, as well as our concrete barriers that go on the roadside. A rigid barrier refers to both of those. The old index has only TL3 guardrail options. The new index has both TL3 and TL2 guardrail options. So the TL2 is a little less robust, and that might result in some cost savings when you're able to use it. The old index, the length of need, uses a simplified method based on AASHTO criteria from several decades ago, so it's about time to update that. So the new index will use length of need calculations that cover more cases. They get a little more specific. They handle bridge skews and things like that. And they're also based on now the latest AASHTO roadside design guide criteria. We could end up with more efficient designs, in some cases shorter guardrail, and in some cases our previous design criteria wasn't providing guardrail that was long enough for the new criteria. So it's important to get in sync with the rest of the country. Okay, so start off with the basics. Where is it? Essentially, it's easiest to Google FDOT standards, and that'll take you right to the page. Alternatively, the link is right here. So essentially, that would bring you to this home page, the Design Standard ebook home page. You want to look at the latest year, 2016-17. And you click on the DSR, because currently this standard is a DSR. I think right now it still happens to be the only DSR on that particular website, so it'd pop up the DSR page, and then you'd have your index sheet links right here. We also, just while we're here, might as well show you kind of the one-stop shopping setup of the standards. If you scroll right in the columns, you see that the instruction for design standards that go along with this index is just located directly to the right. We also have our new design tool, which is our Link the Need program. It has an XLS link because that's for Excel. We provided all the new DGNs. Everything is drawn to scale. If you had to do a project-specific design, you can go ahead and modify those. You probably have to sign and seal them, but at least it gives you a starting point. And then the associated design bulletin, it tells you how to implement this thing, is listed right here. So you just click that link. And then speaking of that design bulletin, the Roadway Design Bulletin 1601 contains the implementation schedule. So the index sheets right now that we're going to discuss, we're basically going to talk about the DSR that was released on February 1st. Right now that's considered part of the 2016-17 ebook, but it's a DSR to that ebook. Specifications we're going to talk about will soon be modified special provisions available from your district office. So currently, you do have access to seeing what the specifications might look like, just looking at the draft specs, the draft specifications of those MSPs, as well as the PPM language that's going to go along with this standard, are currently in Bulletin 1601. So really all the kind of the background information you're going to want to know about using this are in Bulletin 1601. These documents are available for use at the option of the district for all projects let prior to July 1st, 2017. So currently, this DSR is considered optional. If you're going to use the option, you'd want to place the DSR reference number on the key sheet as described in the PPM, Volume 2, Section 3.2.8. That's a new process. You used to have to include the drawings, but that's no longer the case. Let me just go back to the previous slide. You can see right here, there's a DSR reference number, and this is something new, and for every year, every drawing or index is only going to have one reference number, and so you insert that reference number that you happen to be using on your key sheet, and then you'd be good to go. The second thing you do is request the applicable MSPs from the district specifications office and include them in the project specifications package. And that's for the option of all projects let prior to July 1st, 2017. Then, as of that date, July 1st, 2017, this update, everything you're about to see, will become mandatory because it will be released as the 2017-18 Design Standards ebook. So it will be included with the next ebook. The ebook gets released on November 1st, 2016 of this year, and then it will be applicable on July 1st, 2017. Okay, and with that, we can go ahead and move into sheet 1 of the design standards. We're just going to walk through each sheet one by one. The way this is laid out is the sheet numbers are listed in the upper right-hand corner, so you know which sheet we happen to be talking about. And each sheet is kind of broken up into its own little section where the sheet begins with a clipping of the entire index sheet, so you can kind of get a bigger picture of what we're looking at. And then the sheets that follow that might zoom in on some details that we're going to talk about. But the sheet number we're going to discuss is always up here in the upper right-hand corner. So you can see we have, obviously, our table of contents and our general notes to start things off. You can get a feel for the way the general notes look. As I was saying, we start off every note kind of with all caps, explaining what the topic is so you can quickly find what you're looking for as opposed to the previous standard. All right, so we'll take a look at the table of contents just to get a feel for it. As you can see, we made an effort to put all the subjects of the titles at the start, so they're kind of all grouped together and your eyes can quickly find what you're looking for. So sheets number 2 through 3 basically will describe, an introduction to the guardrail, so the TL3 and the TL2 guardrail, and just basically how that looks. So that's basically like the bread and butter repetitive type guardrail. If you're looking at the standard for the first time, that's kind of where you'd want to start, is just to see the simple repetitive guardrail. Sheets number 4 through 5 explain the basic components, so that's your panels, your posts and offset blocks and things like that. Sheet number 6 goes into some guardrail cross sections. This is where we compiled a lot of information in terms of all the grading that goes around the approaches of the guardrail. Sheet 7 through 12 explain some information about some of the end treatments. This is the point where I always point out terminology change. Essentially, in the past, we've always referred to something called an end anchorage assembly that you'd put on the approach ends of guardrail. That did conflict with what was in AASHTO Roadside Design Guide, where they call anything an anchorage to be on the trailing end. So we've changed our terminology a little bit, and it's real easy to understand because just by knowing the name, you know what it's used for. So now we have approach terminals. It was formerly the end anchorage assembly. On the APL drawings, or in the APL section, it now says approach terminal, and then in parentheses, end anchorage assembly. We'll let that stay up there for a year or so, and then we'll sunset the end anchorage assembly term. But approach terminal goes on the approach end. That's designed for head-on collisions. Trailing anchorage goes on the trailing end. It's not designed for head-on collisions. So just so you know. And then we have our CRT end treatment as well. And that's for your short radius systems. Sheets 13 through 16 explain the transition connections to rigid barriers. That was formerly what we refer to as detail J. And that's just connecting to your bridges and your concrete barriers. Sheets 17 through 18 show example guardrail layouts showing how all the segments fit together. So previously we've defined now a lot of different guardrail segments, and then sheet 17 through 18 basically shows how they'd all work together, and if you're designing minimum guardrail lengths, you'd put those segments together to the minimum length, and it's displaying that for the contractor in a way that would coordinate with your plans. Sheet 19 through 20 basically shows any guardrail supplements such as rub rail and pipe rail. Sheet 21, we've consolidated all the different modified post mounts. So if you happen to be trying to run your guardrail over a concrete structure like a curb inlet, or if you need a shallow mount to go over utilities, or if you have to mount posts that go through concrete sidewalk, those would all be covered on sheet number 21. You use special posts for those. And then sheet 22 just covers a little more miscellaneous details like barrier delineators and the button head bolt system. And we've also set up some patterns for when you're trying to reduce the post spacing, to reduce the clear space requirements. The standard actually handles your post spacing transitions, and that's all covered on sheet 22. Okay, now looking at some of the notes, I just want to point out that going forward through all of our sheets, only the first few sheets will kind of dive into some of the notes just so you guys have a feel for it. After that, we'll mostly just focus on the drawings. But here, we'll take a look at the notes because it happens to be the general note sheet, so you guys have an idea what the contractor sees. So it's basically telling the contractor to use specification 536, and no specific shop drawings are required. So if you have the APL drawing and the design standard in your plans, we're saying that, okay, that's sufficient for construction. You don't need any project-specific shop drawings. Note number 2 explains that this is considered 31-inch height guardrail based on Midwest guardrail design. Believe it or not, we have gotten that question ever since switching to MGS guardrail, which is the 31-inch height, because we measure our guardrail for alignment purposes to the mid height of the panel, and because of that, it's not just obviously apparent that it's 31-inch height guardrail. Although if you do look at the drawings, you can see that the total height of guardrail is 31-inch, and so this is considered 31-inch guardrail. So we made that clear in note number 2. Note number 3 explains that the components are based on the AASHTO AGC ARTBA design. That's basically this Joint Committee, a guide to standardized highway barrier hardware. This has been around for a couple decades, and it's really all the compatible pieces of guardrail that are used throughout the country. And we just wanted to put this here for the contractor. We've made an attempt to define everything very clearly in our standard in terms of all the pieces they're going to be using. But if they want additional information, they can check out this guide to standardized barrier hardware, this website. Last time I checked, it was in metric. They're converting to English units. But anyway, that's a helpful resource if you want to look a little deeper into the guardrail parts. Notes number 4 and 5 explain what specifications are to be used for post bolt types and the hex bolt types. Note number 6 explains the asphalt type, what specs to use for that. Note number 7 explains the options for the contractor when the posts fall within 4 feet of a sidewalk or shared use path. And the first option would be just to use timber posts, and then the only other actions that would be required by the contractor would be to trim off any protruding nuts or bolts to not snag any pedestrians, and that's what's covered in this note here. The other option is that the contractor can use steel posts, but then they would have to use pipe rail, and we'll show you that on later slides. Okay, so note number 8 explains how to connect to existing guardrail. The main difference between our new guardrail systems and the existing legacy systems, or most of them out there, is that the existing older systems are 27-inch height, whereas our new height is now 31-inch. And then the existing guardrail systems, most of them have their splices located at the post location. And now we have to locate our splices out at midspan. And I'll show you some pictures of that coming up. But for now, we'll just focus on the height transition. The previous standard was pretty prescriptive in terms of how to transition that height. And it told you, you need so many posts and certain types of panels to transition from 27-inch to 31-inch height. We're really not concerned with being that precise anymore. We're essentially saying that if you can transition from a 27-inch height to a 31-inch height over a distance ranging from 25 feet to 31 foot 3 inches, then we're essentially good to go. These happen to be increments that are panel lengths, and so that's easy to follow. And really, all we're trying to avoid is kind of like an instantaneous change in section properties. And then also aesthetically, we just want it to look nice. If it jumps up a height immediately, it's going to be pretty obvious that you have two different kinds of guardrail. And so we just have a nice smooth transition between the two. And it's pretty simple. You're basically just raising up out of the ground the new guardrail by 4 inches. It has the same posts and everything else. Note number 9 explains the plans callouts and kind of how they work. Throughout this standard, that'll be a recurring theme. We have things called out like begin-end guardrail station and begin-end taper station, and those will really correspond to what are in the plans. So there's some continuity between the designer's plans and the standard, and the contractor can easily follow along. And so we have throughout our standard what will be considered plans callouts that'll coordinate with the callouts in the plans. And note number 10 explains quantity measurement for guardrail. And when we go to the IDS, I'll show you more specific examples with pictures of how to measure length of guardrail. For now, the note is basically saying that wherever there's a begin-end guardrail station called out in the standard and in the plans, that's where you'd begin your guardrail measurement. It's typically post 1 to post 1, or it'd go post 1 to your connection with the rigid barrier. It includes the entire length of guardrail, and we'll explain why that is coming up. Okay, so moving on to sheet number 2, we got pictures and details to look at now. So this is our W-beam configuration for TL3 guardrail. This is considered the general type of guardrail. I think the pay item even reflects that name. So this will be used most of the time. It applies to all TL3 conditions. That's basically all design speeds where you'd use guardrail. This is really the equivalent of what was used in the previous standard. I think mostly everything is the same. So we'll go through those details. I have some pictures of that type of guardrail. You can see the 6 foot 3 inch post spacing. And one thing I like to point out, this looks like a crash test at Midwest Guardrail Research Facility. And one thing I like to point out is this impact angle. Guardrail in general is designed for the steepest impact angle of about 25 degrees. Certainly not designed for 90 degrees or anything even steeper than 25 degrees. And so we do have some fairly strict criteria of telling the offset of the guardrail from the road, knowing that it has to run parallel to the roadway. We have seen some cases where designers just think, oh, guardrail's better than nothing. If you happen to have a canal that you're approaching from a 90-degree angle, and some designers will think, oh, let's just throw some guardrail in there. It'll be better than nothing. It'll help shield the canal a little bit. That could create more of a hazard than the canal itself. In a lot of cases, if the guardrail gets hit from too steep of an angle, it could end up flipping the vehicle. Or in a lot of cases, the guardrail is just simply not designed to handle that much energy, and the vehicle will just punch right through, and it'll become very unstable as it heads towards the water, rather than giving the driver some more ability to control the vehicle as he heads towards the water. So essentially, only design guardrail as we've prescribed it, where it's essentially running parallel to the roadway, And then we also have some taper rates, maximum taper rates, the deviation from being parallel to the road. And we'll get into that when we talk about the IDS. So 25 degrees max is the way these things are crash tested. Okay, so again, this is a 31-inch height guardrail, the 6'3" post spacing, and you'll get used to hearing that number. Most things with guardrail involve that 6'3" space. You have your mid-span panel splice right here. This is something that's new and very important to the Midwest guardrail system, the MGS guardrail, or our 31-inch height guardrail. And what they were finding was with the previous legacy guardrail systems, they couldn't handle as much capacity because their splice was located right on this post. And what happens is when the splice is located right on the post, if a vehicle impacts that, all those splice bolts feel a tremendous shear force just trying to tear off the bolt heads essentially as the vehicle tries to punch through. So by moving this out to mid-span, now most of the stress that the bolts feel is that longitudinal stress rather than the lateral braking stress. So that actually creates additional capacity just by moving the splices out to mid-span, and that's something they discovered through crash testing. 2-inch miscellaneous asphalt pavement, that's the Mow strip that goes right below. That's still shown. That's the same as our previous standard. That just helps prevent the grass from going up underneath, makes it easier to maintain. And then you have one offset block per post. So this is essentially the same system as the previous standard. It's just detailed more clearly. Okay, so looking at some of the notes. Contractors must use 12-foot 6-inch or 25-foot panels, but they may use a 6-foot 3-inch panel at the end of the run. That is something that's new. In the past, we've only allowed contractors to use 12-foot 6-inch panels, and so the designer was told you have to design guardrail to the nearest 12-foot 6, and unfortunately that might limit some of your options in terms of just where you can fit guardrail. So now we have a little bit higher resolution as a way of looking at it, is you can now try to squeeze guardrail somewhere into the nearest 6'3". And so we told the contractors that they're allowed to do that. They can only use one of those 6'3" inch panels right at the very end. They'd add an extra post, and it's in theory would function just about the same way. Note number 2 talks about mid-span panel lap splices. So now we've made this a little more clear. You can see here you might have vehicles traveling in the picture from right to left. This panel here would go over top that panel, so where you have an exposed splice ridge right here, and you want to put that downstream just because that's optimal to avoid any kind of snagging. If you have a vehicle impacting it backwards, there's a small chance that could grip the vehicle and take the guardrail pieces apart. So just optimally, you'd want it downstream, and so that's what we're saying is to place it like that for the final condition. Now the other note is we're saying orientation is not required for traffic control phasing. We've received calls from contractors where they're wanting to know if they have to pull the panels off, put them all back on every time the traffic reverses direction. We've actually heard of contractors doing that. And so we just wanted to make it clear that, hey, you do not have to pull off the panels and redo them every single time you change traffic control phase. You just place them for the final condition. So now the contractors know that. And you might be able to guide the contractors on that as well. And then the last note explains that general guardrail is the base configuration. And so if you quickly look back at it, you can see, okay, we got our mid-span panel splices, our height, our post spacing. All those things are considered the base configuration. And then anything you want to add to that, you would call that out as a designer, so it would be considered modified. So you can say add pipe rail between this station and this station, or add double-faced guardrail between that station and that station, and it just adds on to that base configuration that we saw on the previous page. You can add rub rail, deep post, special post, etc. It adds on to that base configuration. So it's explaining that to the contractor. All right, moving on to sheet number 3. We have our low-speed TL2 guardrail details. Essentially, we got double the post spacing now. So this is something that's new. We haven't seen this in any previous standards. The idea is to have some cost savings by having half the posts. Obviously, it's a TL2 setup, so it's only permitted for design speeds 45 mile per hour and less. So anywhere you have a low design speed, there's a potential for some cost savings if you can get away with having a less robust guardrail. One of the caveats to this is that it has only been crash tested without, F-curb or raised curb. And because of that, we're not allowing any type of raised curb in front of it. There's so much spacing between the posts here that there is a potential, if a vehicle happens to be bouncing up and down or it's unstable, there's a little less vertical stability in this guardrail panel system. And because of that, we really do just want to only use what has been crash tested. And so we're not allowing any type of curb to be placed in front of this that may cause some vehicle vaulting or instability. We want to make sure the capture rate is what they got in crash testing and the vehicles aren't flying over it or passing under it. And so no curbs are allowed with TL2 guardrail. Here we just have a picture. As you can see, it's a fairly large pickup truck. I believe this is actually a MASH test. And again, looks like that 25-degree impact angle. You can see type of post spacing and guardrail we're not really accustomed to seeing around the state yet, where you got 12 foot 6 inches between the posts, so they're nice and spread out. But the crash tests do show that it will do an effective job. If you keep the design speed low, keep it TL2, 45 mile per hour or less, even a large truck like this, you can see that the guardrail deformed. It looks like it absorbed that energy nicely, redirected the vehicle, and now the vehicle's still upright. And so that's a nice result that we're trying to get. And so you can see that the guardrail, even with that wide spacing, still works. So a low-speed guardrail is the same as general guardrail, except it has 12 foot 6 inch post spaces, as you can see, spread out more. It still has the midspan panel splice. Now the only thing about using this TL2 guardrail the contractors would have to understand, and it helps to know this as a designer too when you're trying to lay things out, fit different segments together, is that in order to have this nice run where you have 12 foot 6 inch spans with midspan panel splices, in order to connect to adjacent segments, you're going to have to use a panel that's like a 3/4 length panel. And the reason for that is because every one of our segments that we're going to show you moving forward, it ends with a 6 foot 3 inch space and a midspan panel lap splice. And in order to have everything be nice and compatible and have all the drawings remain the same, when you connect the TL2 segment to it, you're going to come in and this would be your 3/4 panel right here to make that connection. And so that's how that works. So you use a 9 foot 4.5 inch panel, and that's detailed on the following sheets. Okay, so some notes. You'll find that these notes are very similar to the TL3 guardrail. Again, contractor must use the 12 foot 6 inch or longer panels for the continuous run, but they may use a 6 foot 3 inch panel in post spacing only at the end of the run. And that's the same as the TL3, and that's perfectly acceptable. All that does is provide kind of the resolution for designers that are trying to fit something into more of a tight space. You can design it now to the nearest 6 foot 3 as opposed to designing the nearest 12 foot 6. And the remaining notes in here are similar to the TL3 guardrail, so we'll just go ahead and pass over those. Okay, so moving on to sheet number 4, we'll discuss the W-beam and Thrie-Beam panel details. Really, compared to the previous standard, managed to consolidate these panels and show them all now on a single sheet. We did it by using a table to define all these different types of panels. And these panels will be used with the general guardrail, low-speed guardrail, the approach transitions, all throughout the index. Some traditional panel jargon we have is our full panel is 12 foot 6. Historically, that was the largest panel that was allowed to be used. We now have this double panel, which we'll discuss in a minute, explain why we now permit that. So the half panel will be 6 foot 3. The quarter panel spacing is at 3 foot 1.5 inches, and that's something you hear a lot is the quarter panel spacing, because that refers to the slots for the connections to the posts. So basically your post slot connections are at quarter panel spacing. And just knowing that, now you can define all of the lengths of guardrail just by calling out n number of spaces for these post bolt slots. And so you can see here, if you had a 12 foot 6 inch panel, you have 4 post bolt slot spaces at 3 foot 1.5 inches, and it adds up to 12 foot 6. And you go ahead and define that. Every one of these panels has splice bolt connections on the end, and so they're easily defined with one table. Okay, so taking a look at our new panel types, we have the 6 foot 3 inch panel that may be used at the end of the run. Another reason for that is that it may be used to meet the new guardrail length tolerance of plus or minus 3 foot 1.5 inch. This comes from specification 536, the new version that we've just developed. We won't talk about too much in these specs today, but it is important to understand this one tolerance from a designer point of view. And the idea was that inspectors out there in the field had gotten pretty strict with contractors at times, trying to hold them to a length of the nearest inch or the nearest decimal, and there really wasn't a whole lot of guidance for that. And so what we would see is contractors out there trying to field cut panels. That leads to some corrosion issues, and we really just want to avoid that. It's really not necessary to be that close. It's not really building a Swiss watch when it's along the side of a freeway so long as you're meeting your length of need requirement, plus or minus 3 foot 1.5 inches is sufficient. And then using a 6 foot 3 inch panel allows the contractor to always meet that. Now, one caveat to that, it is kind of a common sense thing that we put in the specification as well, to where, okay, well, if you happen to have a guardrail in more of a tight area, we are going to leave it up to the CEI or the engineer to then override that tolerance. And the idea being, if you're in an urban area and you really do have to terminate prior to a sidewalk or prior to a side street, we want to give the engineer the ability to tighten up that tolerance a little bit, just so that, you know, it falls outside of a sidewalk, or basically the guardrail will end only where you need it, but not necessarily to the nearest decimal, the nearest inch. And so moving on, we have basically a 3/4 length panel or 1 1/4 length panel. This may be used to transition to mid-span panel lap splices. Basically, you're transitioning from existing guardrail by using these panels. So we had talked about how you would transition the height over a certain length. And so this basically covers the transition to existing guardrail, where all you're trying to do is get to the mid-span panel lap splice. And so you use one of these panels and you get to the mid-span panel lap splice as soon as possible. So looking back at this slide, you can imagine, as I was saying, the existing guardrail configuration would have the lap splice would be right here at the post location. And then say you're adding new guardrail to the right. You want to get out to that mid-span panel lap splice as soon as possible within that new segment. So you can see that the distance from here to here would be 6 foot 3 plus half a 6 foot 3, and that would give you your 3/4 panel. And you go ahead and just put that in and say this would be the existing splice, that's the new splice, you're out at midspan, and you're good to go. If you put in a 1 1/4 panel, you would end up just to the right over here, and you also end up at a midspan panel lap splice. So that's another option, is to use a 1 1/4 panel. 25 foot panels may now be used to reduce the number of splice bolt installations required by half. This is a really good cost-saving measure for contractors. They're really in favor of this. We actually spoke with some of them. They could easily fit 25 foot panels on their trucks, and what that does is it saves on a lot of man hours. You know, these have to be physically tightened by people, every single one of these splice bolts. So if you can get rid of half of those, you could save a lot of project time, and contractors really like that. Historically, we had a maximum of 12 foot 6 inch W-beam panels. The reason for that is because we had received pushback from maintenance through the years, where they said, oh, you can't use longer panels because we can't fit those on our trucks. But really, the idea is you don't have to replace panels exactly in kind. If a 25 foot panel gets hit, typically when panels get hit, it would be 2 or 3 12 foot 6 inch panels. So if a 25 foot panel gets hit, maintenance personnel are permitted to go out and replace this panel with 2 12 foot 6 inch panels. That easily equals a 25 foot panel. If you splice it together properly, it should function correctly in the same way. That's how they're designed to work. So in short, maintenance personnel can replace a 25 foot panel with 2 12 foot 6 inch panels without causing any problems. Okay, getting into some of our post and offset block details. We've essentially consolidated all these details now onto one sheet. Try to make them drawn more clearly and easy to follow along. Some of the new things we have are a consolidated steel post type, which we'll explain in a moment. We have new variations of post length and offset block height, and we'll explain why you would use different offset block heights. That's mostly for the contractor to know, but it's nice for the designer to have some background knowledge of the type of thought we put into this. And before we get into looking at our details, we can look at a configuration. It looks like this was in crash testing because you notice the miscellaneous asphalt strip is not here. But it looks like it's showing, relatively the 6 inch steel post and then the 7.5 inch offset block, which is the standard. It's important to understand the 7.5 inch offset dimension of the offset block. And the reason for that would be if you happen to have some in-ground obstructions that you knew about that were kind of flush with the surface, but you knew that they might interfere with the post, the designer has the option to go in and add multiple offset blocks. You could add up to 2 additional offset blocks. And so you would want to know this 7.5 inch dimension because that'll buy you 15 inches to back that post up. And so that's just something important to know. If you ever want to add multiple offset blocks and you're kind of wondering how to do it, that is covered in a section in the IDS. We'll talk more about that later on in the presentation. And just general knowledge wise, you can look it up in the IDS, and that's what's nice about it. It'll give you some guidance on multiple offset blocks. Okay, so looking at some of our posts, we now have 2 post lengths. We have the standard length L, 6'6", This has historically been the length of our post, and so we're carrying that forward. 99% of the time, that's going to be used throughout all guardrail installations. But we have something now called a deep post L as well, and I'll explain that. The standard post L, and again, it's basically the default for your general and low speed and end treatments, approach transitions, and so again, this will be used in most places. The deep post L may be used only for something we call a slope break condition, and we'll define that more clearly in a moment. I have some drawings to show you, but slope break condition is essentially where the slope would be permitted to break right at the center line of the post at this location right here. Normally for a standard post, we require the slope to have to break 2 feet behind the post, and so that may end up buying you some room in your typical section. But there are a lot of rules that go along with that, and so we'll have to explain that a little more when we get to that slide. We also have something we're now calling, it's just the consolidated steel post type. In the past, we had several steel posts with different bolt hole configurations. So depending on whether you're using a W-beam or a Thrie-Beam or pipe rail, we had different posts for that. Really, what we decided and what we've discovered is it's just not required. You can have one post that has all of the bolt holes already prefabricated, and so you're ready to go for any configuration. We briefly looked at some section properties and how this would affect the performance or the moment resistance when you remove the area of some of these holes, and found that wouldn't really be the failure point of the post. And so it's really okay just to have all of your bolt hole configurations in place. That was our determination. We've been continually getting requests from contractors to go ahead and just have one post, and that way they can stockpile one post type. Some offset block details. Basically, timber blocks are the standard. Steel blocks are not permitted except for modified Thrie-Beams. And so essentially, backing up a little bit, we have this steel offset block for a modified Thrie-Beam. It has a special shape to it. It's standardized. That's the only steel block that's permitted. All other offset blocks are either going to be timber, or APL composite offset blocks may also be used as a substitute for timber. So the APL composite offset blocks are generally made of that sort of black composite material. Those are really popular, especially with steel posts. They have little hangers on the top, and so they can hang on the flanges of the post and support themselves prior to the bolt being placed. Also, those little hangers prevent the rotation of the offset block, so you don't have to put in those nails to kind of keep it from rotating. And so that saves contractors a lot of time, so they tend to like those composite offset blocks. 2 Thrie-Beam offset block heights are now given. One is the standard that's used most everywhere. There's Thrie-Beam, and the other one is the general approach transition height. And that's a little bit shorter. And they had discovered through crash testing that when you have an approach transition connection to a rigid barrier, the guardrail obviously has to reduce its post spacing. It gets a lot more rigid, so it behaves a little differently. And what they were finding is that when you have a full height offset block, there was a little bit of vehicle snagging because the offset block hung out below the Thrie-Beam panel, and were getting snagged on those. And so in order to prevent that, they basically cut 4 inches off the bottom of the offset block. And then what happens is your Thrie-Beam bends up underneath it. It kind of wraps underneath it, and the vehicle doesn't snag on it, and it rides smoothly after impact with the guardrail. And so that came out of some MASH testing. And so again, these are things the contractor will know. These are the type of things we think about that have to go into the standard to make the guardrail function properly. And we'll show you a lot more detail on these approach transition connections in upcoming slides. Okay, and so now we've reached the end of the first quarter, and we have some review questions for you guys. When we had visited all the districts, it was kind of fun to get your feedback and see if people were paying attention and see what people knew. And for the most part, all the districts did a great job of coming up with these answers. But I'll just ask the question, pause for a few seconds to see if you could think of the answer, and then I'll go ahead and give you the answer. So what is the post spacing of our TL2 low-speed guardrail? We have a new post spacing. That would be 12 foot 6 inches, so it's double of the TL3 guardrail, which is 6'3". So we're allowing for about half the number of posts. At what design speed is a TL2 guardrail permitted? I guess the big hint there is TL2. So that would be 45 miles per hour and less, as with all things TL2. What length panel must contractors use at the end of a TL2 low-speed guardrail run, and why? And a hint here is contractors must use it. There's an optional panel they can put at the end, but there's one that they always have to use. So basically it's the 3/4 length panel, and that's for transitioning to the adjacent segment's midspan splice. So if you remember, we said that all segments pretty mumuch end on a 6' 3" post space and midspan panel splice. Because TL2 guardrail has 12' 6" spacing of posts in a midspan splice, you need a little bit of an odd length panel to then connect to the adjacent segments. So it's a 3/4 panel length, 9' 4.5". At what length guardrail increment must designers plan a general or low-speed guardrail run? So if you remember previously, we wanted designers to design to the nearest 12' 6" because that was our full panel length. However, now we're allowing a contractor to use a 6' 3" panel with one additional post at the end of all kinds of segments, and this allows you to design to the nearest 6' 3". When else would a contractor use a 9' 4.5" or 15' 7.5" panel? That would be for transitioning to new guardrail from existing guardrail. So if you remember, the existing guardrail has the splice located at the post. We want to get our splice out to midspan as quickly as possible. So without changing any of the post space, you just use one of these panels, and then the very first splice in the new segment is located at midspan. What is the offset length dimension of a standard offset block? So remember, I said this was important to know if you want to use multiple offset blocks to then push the post further behind the face of guardrail, potentially avoiding obstacles. So the answer is 7.5 inches. Okay, so now we're moving into what we call the second quarter of reviewing our index sheets. So we're going to discuss sheet 6 a little bit here. So now we have our guardrail cross sections. And what we've done is, again, we kind of consolidated all the different guardrail cross-section types on one sheet. So you can see the guardrail heights and depths, the depths of the post, the adjacent grading, what basic slopes are required for approaches to guardrail, where the 2-inch miscellaneous asphalt mow strip goes in various cases, what you do if you need to be near concrete sidewalk or if you actually have to mount the post through concrete sidewalk. We've never handled that in the past in our standards, and so that's something we're going to address moving forward to get some better constructible designs out there. Curb conditions, shoulder gutter, and rub rail. So now we cover those things all in one sheet. Okay, so these are some of the drawings at the top of the sheet. So what we're showing here is the heights H and the depths D. These are just generally defined for all your different types of guardrail. And the idea is that later on in the standard, we would just call out H and D, and then depending on what type of guardrail you have, you can just go ahead and fill in the appropriate number. We don't have to show every type of guardrail and every type of height and depth. That's just all covered right here, so you can just swap in and out what type of guardrail you're using. And then the other thing we show is that the grading at the base of the post has been established as 1 to 10, and this is going to be a recurring theme. We're going to hear about this 1 to 10 maximum approach slope pretty much throughout our conversation here as we go through this training. Okay, so we had mentioned before the deep posts exist in the standard. We went ahead and defined them for contractors for the case that they are used and the designer does specify it. So the first thing to understand is the contractor may only use deep posts where it's called for in the plans. So we put these typical sections here. That doesn't mean the contractor can use it whenever they want to. We put notes in there saying the designer has to specify it. So you can see this slope break condition where normally we would require 2 feet behind the post to the slope break point. Now we're allowing it to occur right at the center line of the post. And then, the envisioned use for this, we don't expect it to be used a lot all over our roadways. The preference is still to use a standard post and have your slope break where it should as the default standard of 2 feet behind the post at a minimum. But if you can't do that, if you happen to have a triple R project, maybe you couldn't plan for the right-of-way properly and you're really trying to maximize your section and fit as much in there as possible, you can consider this deep post option, the slope break condition. Now, there are issues that come along with it, so that's why I said it wouldn't be our first choice. The issues that come along with it are that miscellaneous asphalt mow strip. It's really not practical to place that right on top of a slope break. And so because you can't really do that, you do have issues with maintainability and maintenance, and the grass would grow up underneath possibly. Also, you could have some issues with erosion. And so because of that, we're asking that if you're going to consider placing this, you want to coordinate the use of deep posts with the district drainage engineer and the district maintenance engineer. You basically want to make sure that they're aware you're going to place this and hear their concerns. And I would assume that the district design engineer would want to hear the opinion of the district drainage engineer and the district maintenance engineer. Ultimately, the DDE has to approve this. And so you can see that, it is a bit of a strict policy there. We don't intend to see these things being used on really every single project to save room. Really only in the extreme cases where you're really trying to maximize your section and get the most out of it because you couldn't really plan the right of way. Okay, so continuing to look at the guardrail sections, on sheet 6 we have our typical grading and pavement placement detail. It looks like this thing's really packed full of a lot of dimensions. The reason for that is because we wanted a lot of default governing dimensions. And essentially what this is doing, it's providing the basic dimensions that may then be superseded by the differences of other standard guardrail sections. So if these are not defined in other guardrail sections, then you assume that this is the criteria. So you can see we have our 1 to 10 maximum approach, which is pretty much going to be true for all guardrail. That's a new policy moving forward, is basically to say that we're really going to use guardrail as it was crash tested. We want to build our roadway and our infrastructure around the guardrail so that it functions correctly to the safest way it can possibly function as we've seen it in crash testing. And one of those is that you have a 1 to 10 maximum approach slope because that's the way these things are crash tested. We also have our 2-foot minimum to the slope break, so the 1 to 10 just continues on, then breaks right here. Obviously that provides a lot more soil cover around the post, so you're able to use the standard post length. If you did have the deep post slope break right here, then you would obviously need a deeper post because you don't have as much soil containment. So that's the idea, is that you have all this nice soil containment so you can use a standard post. Okay, so looking at the curb and gutter sections, you notice where the height H is measured up from in each scenario. So all of these are going to be a little bit different. And the reason for that is because we're essentially concerned with the vehicle height at the time when it would impact the face of guardrail. So in a case of a type F curb, the assumption is that kind of the vehicle base or the base of the tires would be located at this elevation right here at the time that a vehicle would impact with the face of guardrail, if the face of guardrail was either 0 or 5 inches from the face of the curb. Now, when you're considered behind the curb, which moves this lateral offset a lot further per the ppm, this has to be either 4 feet, essentially between 4 feet and 12 feet per the ppm, whereas here you're between 0 and 5 inches, so that's the difference between adjacent and behind the curb. If you're considered behind the curb, the idea is that the vehicle would have vaulted by the time it hits the face of this guardrail because it would basically pop up a little bit after hitting the curb, may have a little time to settle back down, but essentially your new height elevation where the base of the vehicle is measured from is directly below the face of the guardrail. And so that's where the new H is measured from. It's not measured from the lip of the gutter anymore. Looking over at shoulder gutter, this one is essentially measured from the roadway elevation. So if you're looking at the back of the gutter, that typically equals the asphalt elevation there. And so you're just measuring up here because we don't expect a whole lot of elevation change of the vehicle coming across the shoulder gutter. And I had just mentioned this, I'll focus on it a little more. Our new requirement for guardrail now is that it may be either placed at 0 or 5 inches from the face of the curb. And so in our past standard, the face of guardrail was always just aligned over the face of curb. However, the crash tests around the country now are all basically headed towards having the face of guardrail be 5 inches behind the face of curb. It performs correctly, and the reason for that is essentially just to avoid, your nuisance hits. It's a little bit more forgiving. The vehicle drifts off the side of the road and maybe the driver wasn't paying enough attention. Their tire can then rub along the face of the curb, and then the idea is that you have a little bit of play in there, so perhaps the rear view mirror won't hit the guardrail At that point, they have a little bit of tolerance. I know in the Northeast, obviously they're concerned with snow removal. We don't really care about that too much in Florida, but we also do have street cleaning and the type of machinery and hardware they use. They try to get right up next to the curb, and it just gives them a little more space to work with, so you can go 5 inches behind. And this is how they crash tested it, and it should function in the same way. And so that's the preference. The designer can also specify, again, if you're really trying to save some space in your typical section, you're concerned with those inches, you can go ahead and put it at the face of curb. It's just, you're not helping to prevent some of those nuisance hits. And the other thing is, the way we've written this is 0 or 5 inches. The idea is it's going to be one or the other. Face of guardrail moving forward is going to be defined in the plans, and that's the direction we're headed. Is essentially the designer will be providing the information for the contractor. If you draw it in your plan view in your typical section and it's clearly shown 5 inches behind the face of curb, that is how the contractor is going to build it. We didn't say 0 to 5 inches because we didn't want that to be mistaken for a tolerance and then the guardrail will just drift back and forth out there in the field. It's going to be one or the other locked in. If you wanted to change offsets in your plans, and we'll get into talking about this a lot more in future slides, you want to just call out a begin and end of taper, and it's just a linear taper to get from the 0 to the 5 inches. And that would be how you transition back and forth between the two. But that's the designer's choice, 0 or 5 inches. And again, following the theme of the designer establishing where the guardrail goes, this information does come from the plans preparation manual, section 2.3 for shoulders, and figure 4.4.12 for offset to guardrail. And that essentially helps you design exactly where that face of guardrail should go. And once the designer does that, they draw it in the plan view how it should be built in the field. And so you would have that in your typical section, you'd have that in your plan view, and then that's how the contractor would build it. In the standard, we just have placeholders. We kind of define all the surrounding criteria and all the surrounding slopes that are required, but the designer defines that lateral offset for the contractor, and it's per the PPM. Again, with our shoulder sections, we have all the lateral offsets just called out. However, in a plan view or a typical section or a cross section, wherever you show your shoulder and the gutter feature and the face of guardrail, and you can just call this out with a plan view labeler, that is where the contractor builds it. And so this lateral offset is just a placeholder in the standard, whereas everything else is standardized. Just quickly looking at this would be considered our typical pavement and placement detail. Would define a lot of these little dimensions here, like the 2-foot offset to the slope break. And so it's just not shown here. And so we know that typical detail is taking care of it, and this happens to match that typical detail. An example of something that would supersede that detail, the typical grading and pavement placement detail, is this 2-foot distance where the asphalt then extends out 2 feet from the face of guardrail, whereas by default it's only 6 inches. And the reason for that is that historically in our PPM we typically have basically the shoulder line, and in this case that would just be considered the paved shoulder. And so it makes it easy to keep track of. Shoulder line plus 2 feet is a typical PPM requirement. So you have whatever your shoulder width is, and then you add 2 feet to that. That's where your face of guardrail goes. And so what would happen in that case is the asphalt just extends out to meet that pavement, and so that's how it's shown. Here we have dimensioned out the configuration for drainage. If you notice, it's just an uphill slope right here. These dimensions come out to be pretty much 2 feet or very close to it. This happens to coordinate with what's shown in PPM table 2.3, and so we've just gone ahead and shown all the dimensions so you can understand how it coordinates with the table. In this case, we have a varying miscellaneous asphalt width right here, and the reason for this, we're showing this in the double-faced guardrail detail because you would have a fixed shoulder width. Then in a case where you're approaching a bridge traffic railings, and you have a very narrow median, so you're trying to protect the concrete railing in the opposing lane, and we're going to show a lot more detail on this in future slides. You'll have something called a median crossover guardrail, and when you have median crossover guardrail, the guardrail will start tapering linearly across the median, and when it does that, the miscellaneous asphalt will just keep on extending. The shoulder basically stays put where it is, and this will extend across the median. And so we'll show you pictures of that so you can better visualize it, but we're just basically accommodating the median crossover configuration when this starts moving across the median. Rub rail, since we're talking about medians, we're going to go ahead and mention rub rail. It's essentially, per the standard now, only permitted for the median side slopes between 1 to 6 and 1 to 10. So we're pretty straightforward and strict on this one policy of 1 to 10 maximum approach to any face of guardrail. And that actually includes the median side as well. You need to have a 1 to 10 approach to that. However, we're allowing you to get away with a 1 to 6 maximum slope. But if you're steeper than 1 to 10, then you have to use this rub rail. That helps prevent underride and override. You have a little more vehicle instability when you're approaching at a steeper angle. And so it's been shown to help with that. Okay, so continuing with our guardrail sections, we're going to look at the concrete sidewalk. And this is something that's new in terms of the way we're addressing this. So the first thing you have to understand, and unfortunately we have seen some installations out there that have been incorrect. It may be due to lack of really addressing this in the past, but concrete is not permitted around the base of the post. So you want to have essentially soil combined with low strength frangible material. In the general case of installed guardrail, you would have the miscellaneous asphalt around the post, and we know from experience that's flexible, it tears upon impact. The idea is that you have to allow this post to rotate in the soil. So a vehicle is coming from left to right, it hits this. In order to absorb the energy correctly and perform the way it was crash tested, this whole guardrail system has to rotate in the soil. So unfortunately, we haven't seen installations where concrete was just poured all around the base of the post to mount it right into sidewalk, and I guess it was convenient. They might have had a type F curb here, and they wanted to just use that as the form and pour the concrete right up to the type F. And basically they're encasing the base of the post. And when you have a continuous concrete slab, it's not allowing that post to rotate and perform the way it's supposed to. It's just too rigid. So understanding that, we have a few rules here. We now say you need a 7-inch minimum from the back of the post to wherever your concrete is, and that'll give enough room for this post to rotate in the soil, and the asphalt just breaks away, and that will perform in a satisfactory way. That 7-inch came from the blockout dimension that's been crash tested. Now, we do have another option. If you can't avoid surrounding concrete, you really have a typical section where you really just need that guardrail to go right through the sidewalk. There's really nothing else you can do about it. We do have an option for that, and that's now shown on sheet 21, and it's called a frangible leave-out. And essentially what that is a block out of concrete right around the base of the post. It's just blocked out in a square. It could either be formed out that way or cut out later. And then what happens is that gets backfilled with a much softer material. We've spec'd out a flowable fill because it's like a low PSI strength in our specification. So we actually say 150 PSI max. But what that basically does is allows for a nice level surface. It aesthetically looks nice. It matches the concrete. It prevents, like the foliage and grass from growing up around the base of the post. But then it'll break away upon impact. And so that's a crash-tested means that other states are using. I believe TxDOT has that standardized as well. And so that's what we're requiring now is this frangible leave-out per sheet number 21. And we'll show you the picture of that when we get to sheet number 21. Since we're talking about sidewalks, we went ahead and called out, well, if you're within 4 feet of a sidewalk or shared use path and you're using steel posts, you're going to require a pipe rail. And so the idea here is that when you have steel flanges, particularly the top edges, you don't want pedestrians getting impaled or on bicyclists. That steel flange could snag bicyclists, and the idea is to keep people and pedestrians and hold them just a little bit away from that steel flange and provide a little bit of protection of those sharp corners. And so pipe rail is required when you're within 4 feet of a sidewalk or shared use path. Contractors will always have the option of using a timber post or a steel post. And so you want to assume in your plans for quantity purposes that steel posts are always used and pipe rail is always needed so that contractors expect it and then they have the option of not using it. Moving on to sheet number 7, we're going to kind of change gears here for a whole new topic. Essentially, this is the approach terminal geometry. And This case happens to be for parallel and flared approach terminals. If you recall, that's our new terminology. It used to be called end anchorage assembly. Approach terminal is a lot more descriptive, and it goes along with AASHTO, where everything in AASHTO that's considered a terminal is supposed to be crash worthy for head-on collision, and that's why we use the word terminal. So it basically provides the adjacent grading. It also gives some predefined lengths, LE, that will explain later on how to use those predefined lengths, possibly for designing your shortest length of guardrail you can. And we'll get into that more when we look at the IDS. So here are some pictures. These come straight out of the APL. The idea here is of an approach terminal is essentially to develop the ribbon strength and the redirective capability. Generally that happens by post 3, and that's our assumption. We'll talk about that a lot more in the IDS module. So not only does it develop that redirective capability at post 3, but then it's also crash tested, and it's supposed to function in a way that would redirect the W-beam away from the vehicle upon impact to avoid any kind of spearing into the vehicle. And ideally that is how it's supposed to function. Okay, so some things to point out in our drawing is that we have our begin-end guardrail station called out, and you notice that's at the center line of the post. That's true of most all begin-end guardrail stations that we call out. That essentially goes along with your call out in the plans, and anything you call out in the plans with regards to guardrail would be at the face of guardrail. So your stationing and your offset call out is very, very powerful in your plans. You just use the plan view labeler and get it where you want it. The other thing to note is that the length of guardrail, as I previously mentioned, is measured from post 1. And we'll show you some drawings on how to measure guardrail in the IDS component. Something else that's new is that this taper rate, to get back, you basically have your slope break. This would be your normal typical section. You can see that when you have a flared terminal, the slope break tends to get further and further away from the roadway. Then in order to return that slope break back to your typical section, previously we required a 1:15 rate to do that. That's actually been, we'll say, improved a little bit, or this gets back to your typical section a little bit quicker now at a 1:10, and so it helps you save on space a little bit. That's what's currently the requirement in AASHTO Roadside Design Guide, and so we're going to go ahead and go with 1:10. It used to be 1:15. Now the flip side to that is that we are requiring just a little bit more distance behind the post where this 1:10 slope is maintained. We want a nice level terrain surface back here to help facilitate the end treatment, the end terminal, and the way it was tested. And so in order to do that, we want to have what AASHTO Roadside Design Guide recommends in terms of the flat level terrain surrounding the approach terminal. These things really, if you've watched enough crash tests, you realize the designs are actually quite fickle, where if you have vehicles that are quickly rotating or dropping in elevation, then these approach terminals may not function correctly or may not function how they were crash tested. And we want to give these things every chance possible they have to function as intended, to be the safest for the public. And so in order to do that, we're going to go ahead and follow AASHTO's recommendation and increase that 1:10 requirement. So now it's 6 feet from the face of guardrail. And previously we required 3 feet basically from the back of the assembly. And the problem with that is that, well, designers really don't know which APL approach terminal is going to be used. And so designers have a hard time planning that grading when they don't know what type of approach terminal is going to be used. If you go by face of guardrail, that is exactly what the designer has control over. And so you can easily then control where the slope goes. And it's very important in your typical sections, or maybe it's just in your cross sections, to plan correctly for that soil embankment and make sure that that level terrain is accounted for so that the contractor can build it to the standard properly. Now, one other thing to mention is the flare needs to be 4 foot maximum. This is the same as it's been per the previous standard. When we get to the IDS component, we can talk a little bit more about why this flare is important or why it's used. It essentially reduces length of need, gets the impact head a little further from traffic. All right, so moving on to sheet number 8. It's the same idea as sheet 7, but now we're going to cover curb condition, single face guardrail, and now double faced approach terminals. So looking at the curb condition, something new about this that's required is that type E is essentially required between the limits shown, type E curb. So it could be a good idea now to design the whole corridor with type E curb, and then you don't have to really worry about any transitions. But if you do happen to be using a type F, We do provide instructions for the contractor on how to transition from the type F down to the type E. And really, this is very important. This was the design we had to come up with. We were thinking of a way to maintain water conveyance. We know that guardrail goes in many, many urban scenarios where you have to have this curb and you have to maintain water conveyance. The F shape is simply too high. We know that these things were not tested with high curbs like that. And so the idea is to lay this curb down as flat as possible to cause the least amount of vehicle instability possible when it impacts this approach terminal. And so in order to do that, we said, okay, let's use the flattest type of curb that we have, because we know it causes a little bit less instability when a vehicle hits that versus hitting a really steep type F. Something else that we gave some thought to is where the height is measured from. So only in this particular segment for a curb, the height is now measured from essentially directly beneath the guardrail. When these things were crash tested, the height was measured from directly beneath the guardrail because the approach terminals have some hardware that usually runs along the ground line or a little bit above the ground line. When you put in a curb, if you were to measure from the base of the curb, as we normally do, that's essentially lifting up the soil, covering up that hardware. Wasn't crash tested that way, and so in order to avoid that, we're going to go ahead and give instructions for the contractor. The designer really doesn't have to worry about this too much, but this approach terminal will then rise up a few inches with the curb, and it gets transitioned. So we have our guardrail height taper, but the contractor should be aware of this, and we're just giving you an idea of the type of thought that goes into these things. In your plans, you would want to call out the limits of the type E curb, by the way, and have that quantified. So again, I got a little ahead of myself here, but the guardrail height H is measured from this point. All right, so continuing on sheet 8, we also show an approach terminal geometry for a double-faced approach terminal. The double-faced option has really always been available on the APL, but now it's shown in the standard just for better awareness. In the past, anytime you had a double-faced guardrail and it needed an end treatment, it just basically showed a crash cushion symbol that, the CC. Might have just been more convenient to show it that way. But the crash cushion is the higher price option between the two. So really the default option would be this double-faced approach terminal. The initial installation costs we know are simply less. They've been crash tested to MASH in that case. And so wherever it calls for it, you have to put an end treatment on double-faced guardrail. The default option would be double-faced approach terminal. We have also laid out some requirements for approaches. This is also something that's new, and this would also apply to crash cushions, is that when you're out in the middle of a median like this, we do require a 1 to 10 approach on both sides, a 1 to 10 maximum. And so, in the past, I think we might have allowed a 1 to 10 on one side and possibly a steeper slope on the other. We know these things have been crash tested only at 1 to 10 max, and so we're going to require 1 to 10. And again, that's going towards kind of a little bit of a new philosophy with guardrail design, is that we're going to design the surrounding roadway to accommodate what the guardrail has been crash tested to maximize performance, maximize safety for the traveling public out there. So in this case, requiring a 1 to 10 slope on either side, we realized that in the past we might have allowed a steeper, maybe 1 to 6 slope, maybe for water conveyance on one side. In this case, over the length of LE here, you may have to come up with some other methods of conveying water in order to maintain that slope, so you may require some drainage structures or things like that. But it is very important in order to have this function correctly, and so we're gonna put that in our standards and require that. Outside the length of LE, we have standardized the way you would transition back to whatever steep or median slope you might happen to have. Okay, so moving along to sheet number 9, we're now showing our trailing anchorage, which is our type 2. This is being carried forward from our previous standard. It still functions correctly. Now, it has been renamed. I think it used to just have been called a type 2 end treatment or something similar. Now it's called a trailing anchorage. And we know from AASHTO that anything that's considered an anchorage is only to be used on the trailing end. An anchorage, the primary function is to tie down this guardrail to develop that ribbon strength and the redirective capability almost all the way to the end of the guardrail. And so typically when we're designing to shield a hazard, we require that the guardrail extends at least 6 foot 3 inches past the hazard. And the reason for that is this mechanism here needs a little bit of distance to work. So you're tying down to a rigid point, developing that ribbon strength. It only can go on a trailing end because this is not designed for head-on collisions. If you have any kind of head-on collision, chances are you might get spearing of this W beam through the vehicle, and we do not want that. So this is only used for trailing ends. So similar to our approach terminal, we have our begin end guardrail station. This would correspond to the roadway call out. So when you say you want guardrail to end right here at this station and offset, you then have some continuity with the standard, and then the contractor can carry this forward and see exactly how this all lays out. Also, the length of guardrail would be measured from that point. The anchor block option available in the previous standard has been removed, and really all that was doing was taking this tie down to develop this ribbon strength, moving it out to a concrete block as is shown here. What we found with that is that not only is it more expensive to pour all the concrete and then wait for it and all the time that's involved, it also takes up a lot more space, and so there was really no advantage to it, so we're going to go ahead and delete that. The other thing is that TTI has recently tested their own trailing anchorage, and they found it passed a MASH test, which is great news. And essentially the only difference between their end anchorage and ours is that they have a strut developing this rigidity between this post and this post, but the soil plate tie down has historically been shown to work fine, and so we're just going to continue using our trailing anchorage type 2 as we always have. Moving on to sheet number 10, we have some of our end treatment component details. And essentially all these details are going to be used for the hardware. It's really for contractors just to know, but just to give you a feel for how we've organized this. These are either going to be used on the previous page for the type 2 trailing anchorage, or on the following page for the CRT, for the end treatment that goes on the CRT, which is a short radius system. So it's basically construction stuff. We thought we'd just show you. It's really only one page turn away now. The previous standard, these things tended to be scattered all over the sheets. Trying to keep this a little bit more organized now. All right, so now we've reached the end of the second quarter in terms of our review of the sheets. We can go ahead and go through some of these questions. Like I said before, I'll just give you a small pause to think about it, and then I'll go ahead and give you the answer. So what is the minimum distance required from the back of the post to the front slope break? And this is for our standard general run of guardrail. That would be 2 feet because you want to have some soil containment for that standard post depth. For guardrail adjacent to curb, what's the distance between the face of guardrail and the face of the curb? You remember, we're doing something a little new here. So that would be either 0 or 5 inches, and that's defined by the designer in the plan. So however you draw it in your plan view, that's how the contractor would build it, but it would have to be one or the other. What is the maximum slope permitted for all approach grading to guardrail and end treatments? So it's really only one value now. That would be 1 to 10 or flatter. For what condition are deep posts intended to be used? That would be called our slope break condition. And remember, the contractor can only use it when it's put in there by the designer, and designer needs approval of the DDE. So we don't expect to be seeing those on many projects, but it is a tool in the toolbox. To what distance behind post 1 of an approach terminal must the 1 to 10 slope be maintained? Six feet behind the face of guardrail at post 1. And so we have increased that a little bit just to provide for some more vehicle stability when it may be impacting an approach terminal. What type of curb must be used in front of an approach terminal? That would be the type E curb. It's our flattest curb, would cause the least amount of vehicle instability. So that was the best type of curb we can put in front of an approach terminal. Where is the type 2 end treatment used? On the trailing downstream guardrail ends only. And just by knowing the name trailing anchorage, it just automatically tips you off to its usage, and that makes it a lot more easy to understand guardrail a little bit more quickly. And you also have to consider, in the case of a two-way, two-lane road, you may be in the clear zone of an opposing lane. And so you want to make sure that you're outside of any type of approaching clear zones of any lanes that happen to be nearby. And that would be the only time where you can use this trailing anchorage. This concludes Module 1 for Index Sheets 1 through 10. For Index Sheets 11 through 22, we invite you to go ahead and open Module 2. Thank you.